Okay, now we're going to transform a cubic function, at least one example of a cubic function. Notice there are no parentheses, so all we have is the a and the d, and there is a reflection. So since that's a -1, there will not be a stretch or compression. There will be a reflection over the x-axis, which means this comes down here, this goes up there, and then we're going to move the entire thing down too. And I'll show you the graph, what that looks like. So notice it would have been here. It got reflected. This now is facing downward, and this now is facing upwards. And then we took every piece. And for you, you would just take the integral points would be fine. This point would have been here, but now it's down here. It got moved down to, got reflected, then moved down to. Okay? So that's the reflection and the shift. We moved everything down. The domain and range. Remember what I said in a couple of other videos. For polynomials, even if it's been reflected, the domain will always be -infinity to +infinity. Because look at either of those graphs, even though it's very gradual, they're still going infinitely left and right, either direction. And then for the range for both graphs, they're going infinitely up and infinitely up and infinitely down. So that would be the domain and range. Notice, regardless of how it's changed, the domain and range of polynomial functions, polynomial functions to the odd degree, should always be -infinity to +infinity. Okay, that's it for cubic functions.